It's really great to be here. I am so happy to be in Bangkok for this talk. My name is Gabriel. I come from South Africa. In my day job, I tell computers what to do. Sometimes they listen. And I do this by hitting plastic squares in more or less the right order. Second last talk of the day. Let's finish strong. Okay, let's dive into today's agenda. Before we talk about that, I want you all to pay very close attention to what I'm going to be talking about today, because if you ask me some cool questions at the end, there might be some prizes. Okay, so we are going to talk about, I'll tell you 4 things about me. I will talk to you about coding in the bad old days, what it was like for me before I leveled up with this technique. I will then introduce you to service objects. I will talk to you about how service objects made my life better. I will then hopefully show you what's in it for you, what are the benefits for you. Time permitting, and if the demo gods smile on me, we will build a very simple, naive service object framework, and then we will implement an actual service in it, live, God help me. And then I will talk you through some tips and tricks, and then we can open it up to questions. Sound good? Cool. So, 4 things about me. I have a family, my wife and son. They are here with me in Thailand, and my spider sense tells me that they are busy shopping. That's just my credit card that's buzzing. I have 2 beautiful Cocker Spaniels. That one is Buttercup, and then the one lying down is Blossom, and I miss them dearly, and I will see them again on Monday. I can't wait. And I run a small software development company called 01. So that's 3 things. There's a 4th thing about me, and the 4th thing about me is I play way too much Destiny. Seriously, I'm quite addicted to this game. Hit me up on G-4 PlayStation or G_4 on Steam. Send me a friend request and let's play some Destiny together. Okay, cool. So, I want to talk to you about what it was like for me when I used to write code without any thought going into how I structured it, how I architected it. So, who's seen code like this before? Everybody, right? Who's written code like this? Nobody puts their hands up. I've done it. I'm not proud to admit it. This is actual code. It's been anonymized. The person that wrote that code is, we've locked him up in solitary confinement. Never going to see the light of day again. But yeah, I mean, people write code and put their business logic in views. It's not a very good idea. And the reason for that is because you are mixing business logic, the concern of business logic, with your presentation logic. Not a great idea. Okay. So if this is a bad idea, what is a better idea? Well, we could put it in controllers, right? Yeah, I suppose you could do that. But there is a huge downside to this as well. Whilst you have separated, like view logic or UI code from your business logic, you still have a mixed concern here. You shouldn't really be using controllers for business logic. Controllers are things that dispatch your code to different places. The other problem with this code is that you can only use this business logic within the context of a web request, right? You can't use this logic anywhere else. If you want to test this logic, you've got to stand up your entire web framework, send some parameters in, and then you'll get some stuff out, but that's really expensive and not very flexible. So this is also a bad idea. I think we can agree largely, right? So what would be a better idea than this? How about we put it in the model? That seems like a good idea too. I know a lot of people do this. Slap the logic in the model, call it a day, go have some beers. Okay, maybe, but this also has problems. And if you cast your minds back to this morning's talk with Tim, you will remember that he said something quite a light bulb moment for me, in that your models, at least in the Rails world, okay, Rails has kind of butchered what the M in MVC stands for, but at least in the Rails world, models are your persistence layer. Models are your objects that be. But this code's doing stuff. So why would you put this code that's doing stuff in a class that's meant to be stuff? I mean, the other sort of crime against humanity that we're committing here is we are actually doing some stuff in presumably the user model, but we're also hard coding in 1, 2, 3, 4 other dependencies from other models. The follies of youth, eh? All right. So these are all bad things to do. So they all come with some pretty huge downsides, and to summarize them, these downsides are you will tend to have a single use context of your code when you don't put it in the right place. It becomes very hard to refactor that code and difficult to extend. It's painful to test, and you're mixing your concerns. So these are all things which slow you down, land up costing your business money, lower your quality, make your on-ramp time harder. Like, these are all problems which just, a whole class of problems when you arise when you just do things this way. So there has to be a better way, and for me at least, and I hope by the end of this talk you'll feel the same way, for me one of those better ways is to lean very, very heavily on service objects. So what exactly is a service object for the people in the room that don't know? I'll tell you. It's really effectively just a plain old Ruby object. But here's the source. Here's the magic sauce. It decomposes business logic into manageable, that's the first part, and composable methods and classes. There's a lot happening in those two words, decompose, manageable, decomposes and makes it simple. There's a lot happening there, and we'll dive into that now. Okay, so what makes a service object great? So there are many kinds of ways to do this. There's many kinds of tools that you can use, and we'll talk about the tools in a minute. But what makes a service object great? So, well, it does one thing. A good service object is going to do exactly one thing. It's going to lean very, very heavily on the single responsibility principle. And it does this preferably by a single sort of vague method, like run or call or execute. My favorite's call. You can chain them together. So you can have a very simple service that does exactly one thing, compose them together, and you can then implement complex business logic by chaining them together. And what also is great is if a service object can return you back some kind of context, some kind of usable payload that you can inspect, understand if things worked, inspect the data that came back that you can use. So they give you complex data back. One of the things to understand about service objects is that there are actually two kinds that are typically found in the wild. The first one is an action. It's a very simple service object that does one thing and one thing only. And then you get another kind of service object, and that service object is effectively called a composer. And the composer, its job as a service object is to string other service objects together in sequence and make sure that they execute in sequence, make sure that they maybe fail correctly if they need to fail, maybe they roll back if they need to roll back, that kind of thing. Okay. So that's service objects in a nutshell, what you should be looking for in what they do. But how did things change for me when I started using service objects in my code? Well, the first thing that happened is tests became so simple and easy for me. You take your service object, you take some input, you throw it into it, and then you check some output. You don't have to spin up an entire stack. You just need to test that the input and the output. Given some input, when I run it via this thing, I get this output. Very, very simple. The next thing is changes to requirements become simple. How many times is like someone from business going, oh my God, we need to, we need to stop doing X and we need to do Y. And what do? You don't go, oh, that's great. Like, let's get cracking. Let's do it. What do? You go, sure. You walk away. You have a bitch session with your teammates about how the business can't keep their, they can't keep their stories straight and they want to change things all the time. Everybody's had a story like that, right? I have them all the time. But when you use service objects, your architecture becomes change-friendly. Your blast radius for changes becomes very constrained. I'll show you in a minute. I'll kind of illustrate what I mean by that in a minute. Logic can be swapped out very easily, and logic can be dropped very easily. Okay. So what else changed for me? So reuse became a reality for me. I can reuse logic very easily. I can reuse logic in different contexts very, very easily. It became a much simpler affair for me. My code complexity became lower. We had objectively simpler code. If we ran our code through things like Play and Reek, we would get measurable reductions in complexity. Actual, measurable reductions in complexity. Because our code, effectively just started fitting on a screen, That allowed more developers to contribute, and lowering the complexity of their system sort of ambiently increased the quality of the system. But the number one thing for me that changed, and I only kind of came to this realization a year or two down the line, because I'm slow in the uptake with these things. But the number one thing that changed for me was that my logic flow became explicit. How many times have we been working on something, trying to debug a problem, and we go into one file, we see, okay, it's hitting this route, we jump into the controller calls this thing, that thing calls this other thing calls this thing, and before we know it, we're like an hour deep into a debugging session, we've got 27 tabs open in our editor, and then we forgot, what am I even looking at? What problems am I trying to solve in the first place? Because you're basically doing code archaeology at that point, right? So for me, when I started using service objects, that went away. You have a very clear code path. Your logic flow becomes linear. It doesn't become this maze that you've got to go through. Your sequencing of your logic becomes self-documenting. And because of that, and that's a result of having a flattened structure with minimal or absolutely no nesting. Great. So that was a really big revelation for me. So what could you expect to see when you start using service objects? Before we dive into that, I want to ask you something. What is this? Who knows what this is? What this is? Anyone? Not a trick question. It's a Rails app. Right, there's models, views, controllers. Pretty obvious, it's a Rails app. Okay, so it is a Rails app, but what does it do? Does anyone know what it does? No. Okay. Let me open the models directly for you. Okay. We'll zoom in. Does anyone know what this app does now? Well, I see stock awareness concerns, event, quotes, venue. I don't know. And why don't we know? I'll tell you why we don't know. We don't know because this is what an app is, what the app be. This is what the app is. It's not what the app does. Okay? If we cast our minds back to Tim's talk this morning, we're looking at entities here. We're not looking at the domain. Okay, so this is great if you're DHH. Awesome. Okay. Being able to spot a Rails app at 1,000 paces is wonderful. It's not so great for the rest of us. Okay. So let me ask you now, is it any clearer? Let's zoom in. So we have some composer actions, composer service objects. Then we've got a list of services. Is it a little bit clearer what this app does now? I can see there's accept quote, claim voucher, create event, reject quote. These are not entities. This is what the application does. This is what the application does. And then you can see there's a whole bunch of services which are the individual actions that compose these processes. And we can just go through all of them. Right? A lot clearer, a lot simpler. Let's dive into one of those. So this is the claim voucher organizer. I'm using a thing called Light Service. It's a fantastic gem. You should grab it if you want to use a service object framework. And in here, we can see that we are implementing a call method that takes in some params. The inputs are clear. We're decomposing them then that with block, with call. And then we're reducing it into 3 actions. Find voucher for an event, reserve the voucher, and then claim the voucher. Simple. Anybody looking at that, that takes up a quarter of your screen. You can look at that and you can immediately understand what's happening. If you need to claim, like something's wrong with claiming a voucher, you don't need to think too hard about where to go to probably fix the problem. It's in that over there. Open the class up and see what you can do. One of the things you can look forward to is simpler feature refactoring. Let's use an example of logging somebody in. Okay, so we will fetch a user from an OpenID payload. Okay, we will then, after that, we will create a user for the OpenID payload in case that user is a brand new user, and then we will issue a cookie. Great, awesome. Now we have users that can log in via OpenID and can maintain a session via a cookie. But that business owner comes in and he says, well, I read this thing on Hacker News about how cookies are super bad because of tracking and whatever, and Firefox is blocking all cookies, and he doesn't really understand what he's talking about, but that's okay. And he wants to use this new thing that he saw called JWTs. So what do? Previously, we go, oh my God, like we're going to have a panic and da-da-da and all of that stuff. Well, we don't have to do that. All we can do now is say, okay, well, we're going to throw away the issues cookie action, and we'll put in one that does JWTs. Simple. Your blast radius for these changes has become very, very minimized. And you can take it a bit further. Well, why would you kind of over-engineer something as simple as logging a user in? Might seem like a contrived example, except it's not. Users logging in, simple today, very, very complex tomorrow. And this is what I mean by that. So yesterday we were issuing a JWT, and today what we need to do is we also need to send them a welcome back email if we detect that they haven't logged in for a long time. Or we want to update while you were gone notifications. So you can see how something even as simple as logging a user in, and you'd be tempted to put that in a controller because it's so simple, can become very, very, very complex. And if you don't manage that complex deliberately with thought and focus, you're not going to be able to elegantly do stuff like this. Okay, so testing. Services have very, very easily stubbable or mockable inputs and very simple test outputs. You should treat them like unit tests. Organizers, they take all the code, they put it on a journey through a business process, and they kind of implement the full stack of your business. They implement that process end to end. You should think of these effectively as integration tests. The great thing is you don't have to spin up an entire Rails stack just to test them, and really, just all the objects natively. One of the great things is that you can use service objects outside now of just a web context, because your application is actually just more than just a series of HTTP transactions. So by leaning heavily on service objects, you can now use your business logic not just in web controllers, but in asynchronous jobs, in rake tasks, WebSockets, and now that Rails 6 is out, you can use them in Action Mailbox as well. Very easy to take that business logic from wherever it is and use them in those contexts. And your controllers become super, super boring. What you see here is pretty much every single controller I write nowadays. I have an outcome, I call an organizer, I give it some stuff to some parameters, and then I test, is the outcome successful? Yes, then I'll send some instance variables off to a view. Else I'll render some kind of error message. And that is all your controller ever needs to be now. Doesn't have to be any more complex than that. So let's build one. If the demo gods smile upon me, this should be Fun. All right. So we've got a service object here. We're going to write one. It's a very simple, very naive service object. I don't recommend you use anything like this in production, but it's great as a learning exercise. So we'll write a module called base service. We'll give it an attribute reader of result. And we will give it another one. We'll put a module in here called class methods that has a method called call, instantiates itself, and calls call. And let's implement. Let's inject this in quickly. Okay, let's implement call. So what is call? So call will set called to true, and it will set the result as super. Just call it up from the thing we inherit from, and then it returns itself. Awesome. Okay, we should fail with a not implemented error unless it's been defined. Okay, and let's implement not implemented. Doesn't need to be clever, just a standard error. Okay. Okay, and now we're going to implement a success method, so this thing can know if it's successful or not. So, was it called? Yeah, it was called. Okay, so it's a success. We'll expand on it in a second. So, what is called? Called will read the called instance variable that we set up there in the thing, or it's false. Okay, and something is a success if it is not a failure. So what is a failure? A failure is something that has been called and has some errors. Okay, so what are errors? We'll read an errors instance variable, and it will just memoize to an errors.new. Okay, up, up, up. Let's implement the errors quickly. That's very simple. We're not going to be fancy here. We're really just going to make an errors class that inherits from hash, add error key, error value, and some options which we won't use. And then we will set some keys, which is an empty array, memoized, and we will push the error onto it. And then we will unique it so we don't duplicate errors. Oops. Okay. Save it. All right. Now, I don't normally type this fast. All an illusion. Right, let's make a service object using this service object framework we've just built. Okay, user by name of Ruby, great. We're going to require the service object. We're going to require awesome print. Okay, let's make a class. This service object we're going to use is going to make us rich. Okay, when we run it, it will help us make millions. Okay, we will pull in base service. And we will, excuse me, initialize. It's going to take an argument called step1. We'll just set it in an instance variable over here. And then we will implement call. Okay, so if step1's missing, let's just throw this error out. So step over, give it a key, no plan. Got to start somewhere first, my dude. Okay, and then we'll just exit out early. Okay, so step one. Step one. Step one. 5 minutes, okay. Step two. So who knows? Profit. Awesome. And now we're just going to quickly call it. Step one. Beguile your audience with a contrived example. The outcome is make millions. We're going to call it. Step one. If the outcome is a success, we will print it out. Else, we will show the errors. Okay. And then we can run it. I am going to run it from my backup directory because I think I've taken enough chances. And there we go. Very, very simple stuff. Questions? No. I've got a deer in the headlights stay. Okay, let's start it up again. All right. So let's get into the home stretch here. Tips and tricks. So what you want to do is you want to be cognizant of your naming. You want to name your composers or your organizers after business processes. Very important. You want to name your actions after steps in that process, and you want to avoid putting implementation details in those step names. So, invite friend is a better example to use than create linked user. I would recommend that you pick a service object framework. So Interactor is a great one. Light Service I'm using as well. Whisper's cool if you need something that's like more publish subscribe. And then you can also use DryRB, which is great. There's a lot of assembly required with DryRB, but you get a lot of bang for your buck anyway. My personal favorite is Light Service. One of the things you can do is you can programmatically generate action sequences. So you can see in here, the actions are really just some kind of list. And what I'm doing is I'm taking in some parameter and I'm programmatically generating those sequences. You can see over here, I am putting in add shipping fees as the first action unless a user qualifies for free shipping. One of my favorites is hybrid service object asynchronous workers. So this is cool. You don't need to put stuff in /jobs in your Rails app. What you can do is you can pull in your service object framework, mix in your cyclic worker, and then implement your .call as per normal, and then implement a .perform, which takes in primitives. So strings, arrays, hashes, whatever, the stuff that Cyclic likes to work with. And then you implement a hydrate method that takes those primitives, turns them into rich objects, and then sends it back to the organizer itself, which will then be called with the rich objects. If the outcome is a failure, you can raise some useful error and retry. Okay. That is it for time. Thank you so much, everybody. Kop kun krap. I'm Gabriel. And I was serious about the Destiny stuff. Seriously, like, let's play some Destiny. And then finally, before we get into the questions, RubyFusa in Cape Town, beautiful Cape Town, the most beautiful city in the world. Cape Town, South Africa, rubyfusa.org, the CFP is open. We would love to have you all there. And if you're ever in Johannesburg, South Africa, give me a call. Let's meet up. I would love to take any of you out for lunch because you are all now my RubyConf Thailand friends. Thank you.